Everyone, welcome to the final day of CSEdCon, which is quite sad. I know we've been having a great time together, but I'm really excited to be your host and MC for the last and best plenary of CSEdCon. And we're going to be talking about the 2023 State of CS report. So if you already have your hard copy, feel free to pull it out and follow along. If you don't have it, don't worry, we have plenty left still at registration. So I am excited to welcome up my co-authors. So before I do that, though, my name is Hannah Weissman, and I am the Director of Policy at code.org and the author of the State of CS report. And I'm going to be joined on stage by two of my great co-authors, so BT from the Computer Science Teachers Association, and Josh Childs from ESEP. So I'll be talking a little bit about my section of the report, and then I'll turn it over to them. So we will give you guys a great overview, and you're, again, take it out and follow along. So our big headline this year is that 2023 is the biggest year of growth since 2018. So well over half of high schools in the country now have access to foundational computer science. And when you see where we started in 2018, that is amazing progress, and we should all feel incredibly proud of that. So many more students have access to computer science than they did just 5 years ago. And while we don't have data from 10 years ago, it would be even worse 10 years ago. So we've made so much progress. But I know that we're all a little competitive as well. So we like the national number, but we also like to see state facts as well. So you can see that there really is a big range in the country. There's still states that have a minority of their schools offering computer science, all the way to states that have almost every one of their high schools offering computer science. This map is in the book, along with a lot of other ways to see where your state ranks and see what your neighbors are up to. Importantly as well, just because computer science is offered doesn't necessarily mean that students are taking it. So we are so excited this year to see that there are more students than ever before enrolled in computer science. And so we have over 700,000 high school students taking computer science. Importantly, we actually don't get data from every state, so this number is even higher if we were to get data from all 50 states. We also this year for the first time got data from a ton of states about middle school computer science. So many of us in this room, right, we know that early exposure is crucial. We don't want the first computer science opportunity to be when a student is in 9th grade. And so we had data from 19 states this year that almost 350,000 students were taking computer science at that middle school level. And again, if we had data from every state, those numbers would be even higher. So you can see in the State of CS report, there's a map that shows which states gave us data this year. If your state is not included, please reach out, talk to your policymakers, talk to your Department of Education. We want to get data from every state. It's so crucial for us to have that data to keep everyone accountable, to be achieving our goals, and really making sure that every student has both the ability to participate and then is actually enrolled. It's not just enough that they have a course offered, but we actually want to see all students enrolled in computer science. And so with such tremendous growth and progress this year, some of us might be asking how did that happen? And it's not a coincidence. It's thanks to so many of us in this room here. And a lot of it is due to policies, right? This doesn't happen overnight. This is sustained statewide commitment and effort. And so these are the 10 policies recommended by the code.org Advocacy Coalition. Many of you in this room are a part of that Advocacy Coalition. And while I'm not going to go through all of these policies, what they do is they make sure that there's the capacity to teach computer science. They make sure there's developed and strong leaders at the school and administrative level. And they make sure that students have access and that there's equity for all students taking computer science. I do want to call out that this year, the code.org Advocacy Coalition added our 10th policy, which is recommending that every state implement a graduation requirement. We have seen that even when students have the opportunity to take computer science, they do not all enroll, particularly our young women, our economically disadvantaged students. So a graduation requirement means that every student has an opportunity, an introductory computer science experience, and then hopefully they go on to take more and continue exploring computer science. So again, we love a good map, we love some competition. So here you can see the policy adoption across state. And one of the things that's really exciting that we passed a few years ago is that every state now has at least one policy promoting computer science at the statewide level. And that is really crucial to making sure that this doesn't disappear in a few years, that it is part of the state's education ecosystem. And you can see that we have several states that have all of our policies, which is really exciting. And just like how we're hoping to get every high school offering computer science, we want every state on this map to be that dark blue. So just to give you some quick highlights from this past year, we have 10 states that have 9 or more policies. And these states, it's not a coincidence. These states have really high access and they have high participation because their states have committed and invested at the state level to policies that ensure that their teachers and students are well prepared to succeed in computer science. We also have 3 states this year that joined our 5 other states in having a computer science graduation requirement. So that's North Carolina, North Dakota, and Rhode Island. So within the next 5 years, all these states will be requiring to graduate high school to take a computer science course. This year we had 5 states pass first-time funding, and that is so crucial because we see that once you pass funding for the first time, it's so much easier to continue funding computer science, to continue investing on the state level. So we had Illinois, Louisiana, Michigan, my home state of Minnesota, and New Hampshire this year. And that contributed to more money than ever before being allocated to computer science education. So we had over $120 million, and that's just at the state level. That doesn't include any federal grants, any money from private or matches. And so more money than ever before has been flowing in to ensure that our teachers are well equipped and our students are prepared and excited for computer science. Now, every year, right, we want to keep it interesting. We don't want to have the same old thing every year. So among the many new things in the report this year is looking at the data by school size. And so, as some of you may be aware, we actually have so many small high schools in this country. Over 50% of the high schools that are in this country are actually under 500 students. And what we discovered this year is that it is so much harder for these high schools to be teaching computer science. And so if we look at this graph here, small high schools are high schools with 500 students or less. Medium schools are between 500 and 1,200 students, and large schools are 1,200 students or more. So if we look at the large schools, they're almost all teaching computer science. If a student is going to a school with more than 1,200 students, they very, very likely have access to computer science. But that's contrasted with that most of the students at small high schools are not having access to computer science. So when we think about that nationally, we're at about 57.5%. To get to that 100%, almost all of our work is going to be in small schools. And as I mentioned for some of you who were at my session 2 days ago, this is not just a rural issue. There are small schools in urban areas, suburban areas, rural areas. These are public schools. These are charter schools. All of these schools need additional resources and help to get computer science offered. We know that in these schools, teachers often wear many hats. There might be less resources, and so we really need to double down and invest to ensuring that students at these schools have access and are able to enroll in computer science. I'm going to turn it over to BT now, who's going to dig way more into the data with you all, and then talk about what we can do with that.
Thanks, Hannah. Yeah, give it up for Hannah. It's a pleasure to be here and to see you all. Again, I'm BT from the Computer Science Teachers Association, and we have a lot to celebrate, as Hannah just shared. And I also want to share some things for us to reflect on and hopefully motivate us, because we have some persistent equity gaps we want to discuss. First, with regards to access, which means offering a foundational high school computer science course, this chart shows access by student race and ethnicity, and the labels are small, but the first 4 I'll highlight are Native American Alaskan, Black, Latinx, and Native Hawaiian and Pacific Islander, and they are all less likely to have access to CS at their high school than their white and Asian peers. And I should also, the good news is all of these bars have risen over the last couple of years. So we are making some steady progress here. I also want to highlight that these numbers are different than participation, which means enrollment in a course. For example, the first chart, the first bar on the left side is 67% of Native Americans have access to high school CS. Far fewer actually participate in CS. That's one of our biggest gaps. And there's a phenomenal report from Capor Center and ACES just released. I'd recommend you read it to learn more about this equity gap. We're going to transition to talking about participation. So participation is instead enrollment in those high school CS courses, and this chart shows enrollment disaggregated by race and ethnicity. And over the last 3 years, participation by race and ethnicity has been fairly consistent. The kind of dark green bar shows the national demographics of that group, and the light green bar shows their enrollment in high school CS courses. And we see across these that nationally, Black, Native Hawaiian, multiracial students, and white students are proportionally represented to their enrollment in the schools. Asian students are overrepresented, and Latinx and Native American and Alaskan students are underrepresented. And in fact, Latinx students are pretty likely to attend a high school that offers computer science, but they are far less likely to enroll in it. There's a strong participation gap here. Latinx students are 1.4 times less likely than their white and Asian peers to take foundational CS in high school. Another persistent gap is with girls. Only 31% of young women are enrolled in high school computer science. This has been the same over the last few years. What that also means is with relative race and ethnicity parity, but this gender gap, we know that girls of color are most impacted. They have that double bind, and that means they're far less likely to enroll in CS. There are other inequities beyond race, ethnicity, gender, school size. To highlight some of these other subgroups, we know that multilingual learners, students with disabilities, and economically disadvantaged students are all underrepresented compared to their representation in the school in foundational computer science. Some good news, the efforts to teach computer science at the K levels have led to less pronounced disparities. And this is true across all or most of the trends. And one example is with gender. So we just showed that 31% of girls enroll in high school CS. In middle school, that number is 44%. And in elementary school, it's 49%. So we see far closer to parity. And these numbers give an incomplete story. And that's because we can see where CS is offered. We have data around who takes it. But we don't yet know at scale what that experience is like for them. Because really it matters the interactions between students and their teachers. So in the report, you'll find a number of quotes and stories embedded throughout that try to paint a better picture about what is driving that work. And I'd be remiss if I didn't acknowledge the incredible work of the K-12 teachers that lead to these changes and are disrupting inequities and are creating inclusive environments for their students that lead them to want to continue to pursue CS. So I want to take a moment to thank those teachers. Yeah, let's do that. And as the world's largest CS department, CSDA is here to support them and help connect them to other teachers. So we welcome you to join our department as well as invite teachers to do the same. Now I'm going to turn it over to Josh, who's going to talk about how to use the report.
Thanks, BT. Appreciate it. And we appreciate the partnership that we have with Code.org and CSTA when it comes to producing this report. A group of us last night went to dinner and then to the Sphere. How many of y'all went to the Sphere or went to some show? There we go. Look at the hands raised. And it reminded me, or really helped me to really double down on the fact that CS matters. CS education matters. And all of us in the room are committed to seeing its growth, seeing it sustained, and seeing more and more students and their families and communities getting impacted and access and participating in computer science. And so, as thinking about how do we use this report, after you've flipped through the pages, I don't know about you, when you get a nice new book or report, I like to sniff it a little bit, get that new smell in me. What next? How do we use it? And so I think about the student. The name of the session is The State of CS in 2030. So I'm thinking of that student right now who's in their room or in the classroom. They're designing some kind of robotic dog or dingo that might go to Google or Microsoft or NSF one day and say, I want to fund something like this that could help address and answer some problems that are in society right now. So how do we think about this report for what we want to see in the future with CS education? Well, for one, you all have a hard copy that you got at registration. Hannah said there's more that you can get later on. There's also a PDF online that you can provide the stakeholders and folks back at home to know more about the data in their state and about the national landscape around CS education, including state handouts about your individual state and where it ranks in comparison to other states to its similar size and scope. There's also a very unique and very cool data dashboard that's online that provides filters, ways in which to access data based on different demographics and your local school. So dig into that. And you can find that at advocacy.code.org/state-of-CS. And as you think about this work, as we leave Las Vegas later today or tonight on the red eye, how do we think about the work when it comes to expanding capacity? How do we think about the work in CS when it comes to access for students? How do we think about participation in CS for our students in our schools? And most importantly, what's the experience of CS education for students around our country? And so, thinking of this framework that it guides our work in ESEP, developed by my colleague Carol Fletcher and Jace Warner at the University of Texas, how do we think about this work and our work when we're trying to impact what happens in CS classrooms around the country? So now, after this session, after we go home, this is where we kick in. This is where our advocacy kicks into high gear to seeing what we want to see in CS education. So we gotta identify who our audience is. That's educators. That's policymakers. That's industry leaders and community members, students, families, small business owners, all of those that are impacted or impact computer science. And so thinking about how will you tailor your message and your group's message in the back to the relevant audience that you want to see engaged in computer science? And most importantly, who needs to know more about this report and the data that's embedded within the report and online and in the dashboard to help advance this work further? And then finally, how do we advocate? It's not enough to keep what we have gained over the last 2.5 days inside our head, but how do we advocate to that community and to that audience once we leave out of these doors and down those convention steps? Well, first, you gotta ask the question, how will you use the data in this report to make sense of the disparities that BT talked so wonderfully about in computer science? Second, what actions, and this says team, but I want to flip that a little bit. What actions will you take to address these disparities that we've known about, that you've heard over and over again, not just here, but in other conferences? I know it's how us CSEd folks work, right? We go from one week to the next week. We're going to gather at a state summit some other week. We'll get together at another place, right? And we hear the same thing over and over again. So what are we going to do differently when we walk out of this room with this year's report? And then finally, how will you engage individuals from underrepresented populations to develop strategies in collaboration, together, not just for them, but with them, to address some of these deep disparities that we see in CS education? Again, thank you to our partnership with Code.org and the Computer Science Teachers Association for this work. I want to give credit to the other co-author who's sitting in the audience, Sarah Dutton, who I get to work with every day. I'm going to turn it back over to Hannah. That's what I'm getting.
All right, thank you so much, Josh and BT. 20 minutes is not enough to talk about a report that took us months to write, but it's a little sneak peek for you all. So we have put our contact information up here because the report is the beginning of a conversation. Please reach out to us. We want to hear from you. How are you using the report? How can we make it better for future years? This is a product of a collaborative community. We want that conversation to continue. So please, I look forward to emails in my inbox. Hopefully not this weekend, but maybe next week. There was one other thing that we didn't mention, and it wasn't an accident because I didn't want to steal the thunder from the next folks. But one of the other things that is new this year in the report is AI, right? We've been talking so much about AI the last few days and how that impacts education, but particularly how that impacts computer science education, right? That is why we're all here and thinking about how we can best equip our teachers and students in computer science education, and that includes AI. And so that is included in the report. It's mentioned in the executive summary and the introduction, and it actually has its own section this year where it talks about the changing landscape and some guidelines and frameworks for states and policymakers. So that leads me to introducing the next part of our panel, and I'm so excited to welcome onto the stage Patrick Osteen. He is going to be the moderator of the next panel, and they're going to be talking all about AI and how that's going to impact the future of computer science education. So Patrick, I'll welcome you on up to the stage.
Good morning. Let's hear it one more time for Hannah, BT, Josh. Congratulations on the release of the State of CS report. Such a hugely impactful resource for our community, and really taking to heart that call to action in terms of, leveraging this as a resource to go out in the work that we're doing as we leave Las Vegas. So thank you for that. I'm Patrick Osteen. I'm Director of Teacher Skills within Microsoft Philanthropies. We're focused at Microsoft Philanthropies on empowering nonprofits and communities with digital and AI capabilities to really drive inclusive economic growth. And so within that team, I'm focused, and my team is focused on teacher skilling. And so we do that through efforts, whether that's free content, resources, partnerships with nonprofit organizations like Code.org, CSTA, CS for All, and others represented here, and supporting teachers in areas of CS education, AI, cybersecurity, and sustainability. So just wanted to introduce myself for folks that I haven't had the opportunity to meet yet, so you have a little bit more context on myself. So I have the privilege of moderating this panel. Of course, we've been talking throughout the week about the impact of AI on education writ large and the impact of AI on the workforce, but we haven't had as much of a kind of focused conversation on the impact of AI on CS education specifically. What is the future of CS education in the context of AI in education? What role does CS education play in teaching students to learn about how to use AI, how to create with AI, how to create AI technologies, and also how to do so responsibly and with the ethical impacts of computing on society in mind? So lots to unpack there. We have a fantastic panel lined up, three individuals with varied perspectives and backgrounds that I think we're going to have a great focused discussion here. So first up, I'd like to call to the stage Jana De Filippis, who is the Senior Program Manager for Public Policy and Economic Graph at LinkedIn. Welcome, Jana. Next up, we have Jeff Forbes, who is the Program Director for Education and Workforce at NSF's Directorate for Computer and Information Sciences and Engineering. I think I got that right. Please correct me if I messed that up. And perhaps doesn't need an introduction, but I will do so nonetheless, the co-founder and CEO of Code.org, Hadi Partovi. Welcome, Hadi. All right, so I have a range of different questions here, some of which I'm going to ask to individual panelists. Others I'll just open it up to any of you to respond to, and we can kind of build off the conversation from one another. There's a chance we may have some opportunity for questions in the audience, although this panel is a little bit more abbreviated than some of the other plenary panel sessions that we've had. So we'll just kind of monitor the time and see what's possible. But I'd like to start with Jana in terms of your work at LinkedIn and the work that your team does. You recently published a report back in August around the future of work as it relates to AI, the AI impact on future of work in a variety of different spaces, whether that's the roles that will be impacted, how they might be impacted, different skills and how that plays into it. So I think really just centering this question around skills. And so what are we hearing or seeing or learning from industry as it relates to the skills that are needed around AI and specific to CS?
Thank you, Patrick, and it's great to be here today. Let me start by saying that on LinkedIn, we're seeing that AI skills are in high demand and growing fast. Job postings mentioning AI tech like GBT or ChatGPT have shot up 21 times since this time last year. We're also seeing a high demand for AI skills in technical roles like software engineer and data scientist. The top AI skills we're seeing on the platform include the software library TensorFlow or the Python package Pandas, as well as some more general AI skills like data structures or algorithm development. The fastest growing AI skills we're seeing include computer vision, classification, and natural language processing, among others. It's important to note that even for AI jobs, so jobs that have AI in the title, like AI engineer or head of AI, or require multiple AI skills on their job postings, we're seeing a pretty even mix of technical skills and these AI skills specifically, as well as people skills or soft skills, skills like communication and ethics. So it'll be really important when thinking about teaching computer science students and preparing them for the workforce that they're getting an education that includes the mix of technical proficiency and some of these other capabilities.
Yeah, thanks for that. Related to that, interestingly, I was on a different panel a few months ago and kind of asked a related question. And so as preparation for that panel, I had gone through on the Microsoft careers site and had just kind of done an informal look at job descriptions for kind of junior level development positions. And I was looking through the skills that were listed in there. And so many of them are kind of more of those soft skills that you're talking about around communication, collaboration, and teamwork. But also being able to read and interpret code and things of that nature. And you know, of course, there's a little bit in there in terms of, you know, fundamental knowledge and understanding of these data structures, algorithms, et cetera, but a lot around, like, yeah, interpretation of code, working with others on code, being a key piece of that, which I think is kind of reflected in the report as well. One question I have for the kind of the whole group to respond to is just kind of, again, in the space of thinking about the skills that we want students to gain from a computer science class, especially if we're thinking about computer science class in 2030, as it was mentioned, like we're thinking about the state of CS in 2030. You know, a point of conversation that's come up in this community and in CS education over the last several years is that CS is more than just programming, right? There's computational thinking is core to computer science. So computational thinking in particular, curious to get reactions from the panelists in terms of, do you see that, how we think about that evolving in light of generative AI technology? If so, how? And how do we really ensure that students are growing those skills in particular in the future of CS?
So yeah, I do think that this is a pretty big change, and I particularly like what you said, Patrick, about reading code. One of the things, computational thinking was first termed, I guess, by our prior director from NSF, who really wanted to think about, you know, what are the key things that everyone needs to learn in our society today, given that how much computation drives everything. And it's really amazing that, like, a lot of that still applies today, but there has been a real big shift, right? And I think there's going to be an even bigger shift as we go forward into 2030. One of the anecdotes I like is a tweet where someone said they saw someone in a cafe who was just programming on their laptop without using any AI code generation tools. And it's like, what's the matter with this person? It's like seeing someone mow the lawn with scissors. Like, what's going on? But I do think, you know, we do look at what's happening across the country, and while reading code and trying to think about code and trying to do a lot of the other things we expect in computational thinking are expected, it's there's a whole lot more that's people trying to write code, people trying to solve particular problems. And I think we're going to see a lot more in getting back to a lot of the tenets of computational thinking. You know, how do we decompose problems? How do we think about the impact of what's happening? How are we able to ask questions about the data that we have and then know whether those answers are correct? I think there's a lot that we're going to learn as we move forward with our new great tools.
Hi, everybody. I have a lot of thoughts on this question, so I don't know how to answer briefly. The first thing I want to say relative to what Gianna shared about the skills on LinkedIn is, I think, you know, today's job descriptions about AI talk about specific AI skills for an AI job, but when it comes to the types of jobs people post on LinkedIn, we are quickly moving to the point where every single job will have an expectation that you use AI, because every single software tool out there is going to be adopting some form of AI. So if you use Salesforce as a salesperson, Salesforce is going to be using AI to pre-generate emails that you send to people. If you use Photoshop as a graphic designer, that already now has generative AI, and it's going to be almost redundant to say that you need to know how to use the AI aspects of Photoshop. And using AI is going to be part of basic digital literacy. But when we think about computer science and AI, there's probably the greatest change. People have done surveys of folks asking what industries or what professions are going to be the most impacted by generative AI. Number one is software engineering. Number two is teaching. So the combination of teaching and computer science is sort of at this vortex of change, because it both involves changing what we teach and involves changing how we teach it. And both of those things are quite relevant. And what I'd also want to add is that generative AI is just a part of an evolution and is a fast-moving target. So just thinking around how does what we have seen in the last 12 months impact CS education for 10 years from now isn't enough, because there's going to be this ongoing effort by the people creating these AI tools to add a greater level of critical thinking, problem solving, reasoning, removing bias, removing misinformation. All the flaws we currently see, there's somebody or teams of people working to remove those flaws. And so it's going to be challenging to keep up with that, but what is definitely clear is that the rote work of sort of coding is going to be reduced, and the more sort of computational thinking work of breaking down problems or abstraction, those are going to be increased. Even though code.org is called code.org, as people who use our platform know that almost all the coding we teach is using blocks, using the Blockly language, which is how you learn the algorithmic thinking and ignore, frankly, or never even see the syntax, because the syntax is going to be increasingly less important. And so within CS education, teaching how AI works and using that AI to solve problems is going to rise in importance. The actual nitty-gritty of where did the semicolon go and do you close your parentheses, those are going to be less and less the things we deal with, which I actually think makes programming much, much more accessible and focuses on things like the creativity and the things that engage humans rather than the things that make it sort of nerdy and difficult.
Yeah, great insights. Thank you. Perhaps we'll see even kind of more block coding, to your point there, as we get into visioning to 2030, where the emphasis on introduction to computer science really leverages that even more as a way to teach those computational thinking, algorithmic thinking as well. And I like your point too, Hadi, in terms of the impact on teaching and software engineering, and to kind of build into that some of the conversations that have also come up. That doesn't mean that teachers and software engineers necessarily are losing their job. It's changing how those jobs are working, and that's I think an important point to underscore as well. My next question is for Jeff specifically, and it's around just kind of if there's any early research just within your work stream that you've seen into the use of generative AI in the higher ed space, at the maybe CS1 intro level CS courses where there's been experimentation with integration of generative AI tools into those classes, or anything you've been hearing from that community of higher education faculty as it relates to lessons that the K-12 sector could learn from.
Yeah, there actually has been a remarkable amount of work done over the past year, it turns out, and it's difficult because it is such a moving target. But I think some of the lessons that we get, there was a working group at the International Computer Science Conference and the Computer Science Education Conference, excuse me. And what did they find? Well, it turns out these tools work, right? They work really well for introductory programming, right? So what do I mean when I say that they work? Well, they help students complete the tasks. They make sure they complete the tasks and their solutions are better. They're, of course, able to do it in less time. But what's also remarkable is that you would think, well, they're not able to maybe understand as much as one might think. But they've even had studies where they had a group of students aged 10 through 17 working on projects, and half had access to AI code generation tools and half didn't. The ones who did have access to the AI generation tools, of course, did the assignments very well and did them quicker. But also, when they had to do things like code modification without the AI generation tool, they did it just as well. And when you ask them about doing the test, not on the tool, they did just as well. In fact, they, in some cases, did better, especially if this was a camp that was in Python, if they had prior Scratch experience. It turned out that actually allowed them to use the tools even better. Now, it is key that we think about how we teach in these environments, right? That it's not just about what we're teaching, but how we teach and how we prepare to teach, what the resources are that we're going to be providing students. And there's been a lot of work on that, and a lot of work also looking at how faculty are trying to address these issues, because as you can imagine, there's a variety of levels of comfort with this, right? I imagine you all have to do an incredible amount to update a lot of the great tools that you already have out there. That's asking a lot of curriculum developers, or asking a lot of faculty. But I do think this is really an opportunity, based on all the research that we're seeing, that this does have a substantial impact. But it does appear that you still do want people to take these classes, because the impact does get less the higher up the curriculum you're going, right? So now that may change, because one of the things we're finding are the newer tools are better than the old tools. But it does seem to be the case that you do want to learn some of these things, because if you want to succeed in some of the later courses, you do need, currently at least, to have gone through these introductory classes, which have some of the same learning objectives before, but now you're incorporating AI tools in as one of the things that students and teachers are using.
Yeah, thanks for that, Jeff. And I think kind of going up to from higher ed to industry, there's actually been some interesting research that GitHub has done related to the use of the GitHub Copilot technology, kind of code assistance technology, leveraging generative AI. And they've found in their early research of developers that are using that tool that not only are they producing code more quickly, but there's also, in terms of the sentiments of the developers that are using the tools, that they're finding themselves more fulfilled by the work that they're doing, because they're putting aside some of the more time-consuming menial tasks and able to focus their time on what really matters to them. So kind of just building on some of the pieces that you were seeing in the research at the higher ed space as well, Jeff. Curious to kind of zoom in, like, for this exercise of future of CS in 2030. And Hadi, I was particularly interested to get your perspective on this question of, like, if we're sitting in a computer science class, 7 years from now, what do you think that would look like from a pedagogical perspective? What a lot of it, I think, for most of us that have been in a computer science class or computer science teachers ourselves, a lot of time is spent students at their computers coding. Do you expect that to continue to be the case, or how do you think things will evolve in that classroom setting in terms of instruction and pedagogy, and just how students are spending their time? I'm really curious to get your thoughts on that. I know you mentioned previously, Hadi, in terms of like rote work being reduced, and there was a comment earlier from Jeff, I think, about like code reading more than code writing. So kind of pulling together a few threads. Curious to get your vision and thoughts there, Hadi.
I didn't know this question was coming, so I have to think about my answer. And I also would say I don't want my answer to carry too much weight, because I'm coming up with it right now. This isn't like the 7-year plan for Code.org's work.
No worries.
Any members of my team in the room, this isn't like our 7-year agenda. I'd first say nobody knows exactly what things are going to be like in 7 years. I'm not sure at any point you could predict that, but with this pace of change, it's quite difficult. The things I'm most sure of are the trends I mentioned, which is learning more about how AI works and learning more how to use AI, and learning less about rote repetitive stuff. The reduction of rote and repetitive work in computer science isn't a new trend. When my father was learning it, computer science involved punching holes in cardboard, and to represent ones and zeros. Right before I went to college, people were learning an assembly language, because that was the primary way you learned. And each decade, typing code has become closer and closer to English, and we're going to continue on that path. I expect block-based programming will actually increase, and syntactical coding will decrease because it'll be more like, oh, not everybody needs to do that. In fact, I wouldn't be surprised if the generative tools for coding generate block-looking stuff, and you don't need to look at the stuff underneath, because that's the part that the computer definitely has done a better job of. One thing I think I mentioned this a couple days ago, I especially think HTML coding is going to drop in sort of what you teach in a high school or middle school class, because jobs in HTML coding are also going to just generally, those are going to be things that tools like Canva or other tools will just automatically generate HTML for us, in the same way that assembly language coding is not something people do. The one thing I'd say that'll probably, every time I think about it, slightly blows my own mind, and I'm not sure whether this is in 4 years or 7 years or 10. But if you try the current ChatGPT audio like UI where you can speak to it and it speaks back, and you're not typing, it's speaking, that's already here today. We're not very far from a point where an AI teacher can be sort of a person that you speak to that looks like a person. It could even have the visuals of, like, it could be me. Somebody did a 3D scan of me and a measure of my voice, or any celebrity or tech leader or whatever that is your teacher, and you speak to them and it speaks to you and this is not just in CS education, all of education. There's this opportunity to have a real AI tutor, not like a chatbot that types and you need to read what it says. And I suspect we'll see things like that before the end of this decade. How that impacts all of education, I'm certain that the role of a teacher will continue to become more of a facilitator and a coach, and the role of a curriculum developer is going to be more of using this kind of AI to basically not just deliver information, but deliver interactive teaching and coaching. And that's going to be wild in its impacts, but I think it'll increase equity and it'll give a much broader set of people access to the best educators.
Thank you. Yeah, sorry to put you on the spot there with that one, but I appreciate the answer and agree in terms of the pace of change and how much that's impacting the entire education community, and how we all here in this room and other leaders in education, CS education, AI and education, really need to support the community in adapting to these technological changes to support our students. You mentioned equity there at the end, Hadi. I just want to kind of bring it the conversation to that space for the whole panel to respond to as you choose. We saw from the State of CS report that there's been improvements in terms of equity and access, some lags in some cases that were called out in terms of participation. So obviously we're all well familiar with the persistent equity gaps that have existed within computer science education, the technology industry at large. And just curious to hear from the panelists in terms of both the opportunities that are presented, which I think you were just touching on, Hadi, but also there are risks to equity, with past technological innovations that have widened equity gaps. And so definitely a concern of everyone here, I know. So just your thoughts on the risks, the opportunities of AI as it relates to CS education and equity in CS education.
I can start on this one. I just wanted to point to what Hadi said about generative AI helping create accessibility to coding in terms of ensuring that students have more time for the deeper thinking and planning and computational thinking, and less time on the more rotary tasks involved in coding. I think that's a great point. I'd add to it that we're starting to see the potential for generative AI in helping students who may face barriers to traditional learning methods, Gen AI can be a tool in helping individualize learning. In terms of risks, as alluded in the question, we already have equity gaps in CS and in AI specifically. Our own data from LinkedIn earlier this year shows that in the AI field, it is still very overrepresented by men. For example, 70% male to 30% female. And it is so important that these roles are diverse to ensure that the impacts of AI technology, that there are no negative impacts for underrepresented groups. So this is a really critical point. The last thing I'll say on this is that our research at LinkedIn looks at the overall impact of AI on the workforce. I think, Patrick, you alluded to it in the introduction of our report. And what we're seeing is that women and younger workers are overrepresented in jobs that stand to see the most immediate impacts of Gen AI on their jobs. So it's really important that computer science students and professionals who are working on this technology are also thinking about those impacts, and that educators are thinking about how to train and teach future generations in the workforce on learning skills as their jobs may evolve with Gen AI technology.
So yeah, I'm very concerned about like how do we make sure this is going to narrow gaps rather than make them bigger. And I think there are a lot of reasons to worry about perhaps the gaps getting bigger. Prior to being at NSF, I taught computer science at Duke University in North Carolina for 19 years. And one of the things we saw is just the impact of preparatory privilege, right? If you have prior experience and what that means in terms of what you're able to do when you get there. And that could become even larger with access to these tools. And we're even seeing some places where there are things happening in high schools that really are making things worse. For example, at one school, they cut off access to ChatGPT. So you couldn't go through the school's computers. But then the students who had the ability to tether to their phones were still able to get access to ChatGPT. So instead of actually trying to level the playing field, what they did was allow folks who had access to hotspots to be able to do more. So don't do that. But I do think there are great opportunities as well. We are seeing work where one of the big problems on the university level is capacity, right? We don't have enough capacity in terms of teaching assistants and professors to work with all of the students. And there are already some educators who are creating really good, helper bots that do a much better job than, honestly, our TAs and faculty were doing in terms of giving high quality, immediate responses that help people with the problem that they're working on. So I am hopeful, but I do think that this is going to require a real dedication on everyone's part to make sure that we're narrowing the gaps.
I similarly see both risks and also opportunities, but I'm way more optimistic about the opportunities, and that's much more because I think about the long term, not necessarily the, last year schools banned ChatGPT, which was, I think, a big mistake. I suspect when we look 10 years from now, the rise of all AI tools, but especially generative AI, is going to be something we look back as having been one of the greatest equalizers in education. And the reason I say that, first of all, is the access is increasingly going to be anybody who has a phone, and phones already reach a very, very large percentage of the global population, and that's only going to increase. I also would say when I think about equity, I don't just think in the United States. If you think globally, there are places that just the entire country barely teaches computer science, for example, but access to a phone suddenly will provide you access to a personalized tutor. And if you think about not just where CS is taught versus it's not taught, that's going to be easier with these new tools. And then there's places where it's taught and there's places where it's taught poorly. The quality of education is also going to go up because more and more, as the role of the teacher becomes that of a coach or facilitator, everybody will have a much higher quality content experience. And we already see that with the work that Code.org has done, for example. Part of why access to computer science is more equitable is the money we put into training teachers. But part of it is because we've created a curriculum that allows a history teacher to begin teaching computer science because that history teacher doesn't need to be a CS expert because our curriculum and our videos and so on carry some of that weight. And that has enabled an equitable spread of access. When an AI tutor does even more than Code.org's videos or curriculums do, that will actually increase the equitable access. It'll widen the gap between those who do or don't have access to basic digital hardware. But I believe the more value we put into that digital hardware, the more our our global economy is going to spread access, as we see with smartphones. The more powerful smartphones get, the more people end up having them.
Yeah, thank you. Just completely agree with all the panelists there in terms of just this broader theme of the great opportunities that do exist, and for differentiated learning, personalized learning, to really extend that opportunity to more students, and appreciate you calling out, the global considerations as well there, Hadi. But while also being very cognizant and mindful of the risks of widening gaps as well. I think we've got time maybe just for one last question here before we wrap up the panel. I want to talk a little bit about responsible AI and just the role that CSEdCon has to ensure that, and this kind of has two elements to it, both the responsible use of AI, but also the responsible development of AI systems, and for future AI developers out there, and just kind of what role foundational CS classes should play in ensuring that that's part of the curriculum, or more broadly as we think about CSEdCon and the interplay of responsible use of technology maybe at large, not just AI. But any thoughts or reactions there?
So at NSF, we're responsible for trying to broaden participation of the computing research community. And I think that becomes more important because we really these technologies have a much broader impact than they used to. But I also want to say, I'm seeing that this has been a great opportunity in that the impact of technology was always like meaningful and not necessarily always like, nice. And with AI, it's foregrounded. Everyone wants to have a conversation about it because it's real easy to see the problems, and everyone wants to have the discussions about ethics that before I think were a little abstract, but now I think these are things that are impacting students' lives, impacting their families' lives, and people want to engage. So I really think this is a great opportunity for us as a community.
I was going to say that, I think definitely students should be learning responsible AI in terms of if they're going to be developing these technologies, pointing back to the diversity stat or lack thereof diversity in the AI field. So that's really critical. But also I'd say widespread AI literacy, the broader understanding of what is this technology, what are the differential impacts, what are the biases that may exist, and being able to comprehend that. So whether these students will go on to actually design these algorithms or be on the consumer side using them, as Hadi mentioned, in Salesforce or in other software where they will be, I think that's also really critical.
So first of all, I agree with Jeff that teaching about societal impacts has been a part of computer science in the last couple decades. Pre-AI, the CSTA standards for many years have included sort of learning about the societal impacts of technology as part of learning computer science. With great power comes great responsibility, and we should be teaching students not only what a computer could do, but what it should do. And with AI, it is a superpower for anybody who has computer science skills. AI basically doubles those skills, and so it doubles the necessity of making sure we teach students how to use it for positive social impact. And as educators, I would say when it comes to responsibility, our responsibility to democratize access to this education is even greater, because the abilities of somebody who knows computer science have just basically increased. Generative AI, coding has always been a superpower, but coding with AI is now like a double or triple superpower, and that's a superpower that needs to be in the hands of everybody. None of us want a world where a very small percentage of the population are creating the tools and technologies that everybody else are just blindly using. We should all envision a society where every human being has the knowledge to maximize their own personal potential as creators. And that's our number one responsibility as educators of computer science.
What a fantastic note to end on, because we are at time. Thank you, panelists. Appreciate you all. Thank you, audience, for your engagement. I'll pass it back to Hannah.
All right, let's give a hand up for that great panel, everyone. Well, so while this is the last time we're all going to be together in this room, don't leave yet. We have 2 great sessions still happening this morning, both at 10 a.m. and 11 a.m., including some really great lesson demos. So please stay and enjoy that. If you've not yet picked up a hard copy of the State of CS report, I don't know what you're waiting for. We've got plenty out there. I'll be sad if I have to take a lot home. I don't want that. So please make sure to swing by and grab that. We also have state handouts. So please grab one if you want to grab one for a colleague. As Josh mentioned, this is such a crucial tool to advocate. So please take it home to your home community and use it to get more computer science. I have a few other housekeeping things. Check out of your rooms by 11 a.m., please. We do not want the hotel to get mad at us. We do have luggage storage downstairs right by the escalators in the St. James room. So if you need to run up quickly and grab your suitcase, you can bring it down there. And we have several lost and found items, some stray glasses, some stray cords. So make sure to swing by the registration desk to grab all of that. But thank you so much for a wonderful CSEdCon.